All right, guys, there is Unit 4. Unit 4 was dealing with SOHCAHTOA and the Pythagorean theorem, a squared plus b squared equals c squared. If you are doing any SOHCAHTOA problems, please make sure your calculator is in degree mode. Degree, not radian. Make sure you are in degree mode. So let's jump right into questions 1, 2, 3, and 4. I have some special right triangles in here, but it looks like question 1 and question 2 are both about Pythagorean theorem. So a squared plus b squared equals c squared. So in question 1, the legs are 9 squared, and that is plus 12 squared. And that has to equal x squared. The c is always the hypotenuse. 9 squared is 81. 12 squared is 144. And that equals x squared. Add those two numbers together. 81 and 144 is 225. That's x squared. And then I square root that answer. And x is equal to 15. Second one is again Pythagorean theorem. My legs are 6 squared plus x squared has to equal 10 squared. So x squared plus 36 is equal to 100. Subtract 36 on both sides. So x squared is equal to 64. Square root x is equal to 8. Question number 3 is a special right triangle. That is a 45, 45, 90. So that means that my legs are both m, and the hypotenuse is m radical 2. So my equation here is m radical 2 is equal to 10. So m radical 2 is equal to 10. Divide both sides by radical 2. So m is 10 over radical 2. Can't have a radical in the denominator. So multiply by radical 2 over radical 2. So that's 10 radical 2. And radical 2 times radical 2 is 2. And 10 over 2 is 5. So 5 radical 2. That's what m is equal to. So in this case, it says what is x? X is equal to the m value. So x is equal to 5 radical 2. Question number 4, same concept. M radical 2. In this case, my equation is m is equal to 10. So my x value is equal to the m value times radical 2. So 10 radical 2 for number 4. All right, for 5, 6, 7, and 8, it just wants me to write the ratio. So I'm just writing the fractions here for SOHCAHTOA. So angle M, opposite, adjacent, hypotenuse. Sine is opposite over hypotenuse, so 3 over 5. When I go to number 6, it wants me to deal with angle O. So let's start over. Here's my angle. So my opposite side, my adjacent side, and my hypotenuse. And 6, 7, and 8 are all dealing with angle O, so I can leave this picture now for the remainder. Cosine is adjacent over hypotenuse, so 3 over 5. Tangent is opposite over adjacent, so that is 4 over 3. And the sine is opposite over hypotenuse, which is 4 over 5. Numbers 9, 10, and 11 says find the value of x. And we're going to round the segment length to the nearest tenth and each angle to the nearest whole degree. So here's where I have to make sure my calculator is in degree mode. So if angle x is my angle, this is my opposite side, and this is my adjacent side. So I'm dealing with O and A, so it is the tangent of the angle, the tangent of x equals the opposite side, 12 over the adjacent side, 15. In order to get rid of the tangent, I have to use tangent with the -1, called the inverse tangent, or the arctangent of 12 over 15. And that is going right into my calculator. I will hit second tangent 12 divided by 15, and that is 38.65. It wants me to round to the nearest whole degree, so 38.6 rounds up to 39 degrees. Question number 10 gives me an angle measure of 32 degrees. X is adjacent, 24 is hypotenuse. So I'm going to use cosine. So the cosine of the angle, the cosine of 32, is equal to the adjacent side x over the hypotenuse 24. Multiply both sides by 24, so x equals 24 times the cosine of 32. That's what gets typed into my calculator. 24 times the cosine of 32 degrees is 20.35, so 20.4 units long. That's rounded to the nearest tenth. And question number 11, again, here's my angle x, opposite hypotenuse. We're dealing with sine now, so the sine of the angle, the sine of x, is equal to 13 over 17. That's opposite over hypotenuse. Get rid of sine by using arc sine. There's the sine with the -1 of 13 over 17. Type into my calculator second sine. 13 over 17 is 49.8, so that rounds to 50 degrees. Question number 12. In a right triangle, the sine of A is 3 over 4, and the measure of angle B is 46 degrees. Okay, so if I just draw this right triangle, it says the sine of A, the opposite sine, is opposite over hypotenuse. So from A, the opposite side is 3 over the hypotenuse is 4. I could do a squared plus b squared equals c squared here if I wanted to, but I don't need to. It wants me to find the cosine of b. Well, you should know that the sine of A and the cosine of B are equal to one another. So this equals 3 over 4. Find the measure of angle A. Angle A, they have to add up to 180. So 180 minus 90 minus 46. Angle A has to equal 44 degrees. Has to equal 44 degrees. If they asked me to find AC, I would have done a squared plus b squared equals c squared there. And the last question, question number 13, says a ladder leans against the brick wall. So here's my brick wall. Here is my ladder. It's going to make a right angle. The foot of the ladder is 6 feet from the wall, so that's down here, 6 feet from the wall. The ladder reaches a height of 15 feet. So the height of the ladder is 15 feet. Find to the nearest degree the angle the ladder makes with the wall. The ladder and the wall is that angle up there. All right, so from that angle I have an opposite side and I have an adjacent side. So O and A is tangent. So the tangent of the angle, the tangent of x, is equal to the opposite 6 over the adjacent 15. Did x by itself, use second tangent. And x is equal to second tangent of 6 over 15. And round to the nearest degree, it's 21.8. So that is 22 degrees. That one is 22 degrees. And that is the end of Unit 4.